Today we are going to learn Bayes theorem. In modern statistics, Bayes theorem is one of the most important theorem. One field of statistics that is called Bayesian inference is totally based on Bayes theorem. Many critical problems in computer science, biological science, anywhere we can solve by Bayes theorem. So it is very important to know how to derive to Bayes theorem in very simple way. Bayes theorem is developed by English mathematician Thomas Bayes in 17th century. Still now it is very popular. In modern statistics, that is used in data science, in machine learning, used in lot of theorems or lot of machine learning mechanism algorithm is based on Bayes theorem. Even in biological science, bioinformatics, for genetical combination, they are using Bayes theorem. So for every field, it is very important to know the Bayes theorem. Let us know how we can derive the Bayes theorem in simple way. Say there are two events. One is A1 and other is A2. Okay. One is A1 and other is A2. So there is two event. Let us say there is two event. And for the two event, there is a common things or item is B. For the two event between A and B, there is a common item or things B. Okay, it is seen in the Venn diagram. For two event, common is B. So D is also in A1 and D is also in A2. So this is the intersection, that is D in A1 and this is the D in A2. So D is common both for A1 and A2. So, okay. And it is known that already we know the probability of A1 for the whole space. What is the probability for the event A1? Also, it is known that what is the probability of event A2. Okay. And also known that the conditional probability of D, that is the common in A1. Also known that D in B, that is the common D in A2, that is the probability D given A2. So these four things are known: probability of A1, probability of A2, and common thing. Remember, the common always I put the first. That is the common item in A1. What is the probability the common things will be A1, and what is the probability common things will be A2. Okay, remember this. So common in A1, that is D given A1, and common in A2, D given A2. Now we want to know what is the probability A1 given D. That is, in the common, there is a common we find intersection. What is the probability that A1 will be in D? Okay, in D, what is only A1? Okay, this is small conditional probability. How can you know? So we want to know, that is probability A1 given D, or we want to know that probability A2 given D. But first of all, let us know how we can know probability A1 given D. So we know the conditional probability A1 given D, that is A1 in D, A condition D. We can write, we know that A1 intersection D, A and D, and probability of D. This is we know, but we don't know this. We don't know what is the probability of A1D and probability of D. Total probability, we don't know. We don't know the probability of A1 and D or probability only D. We don't know this. How can you do this? Okay, how can you do? So there is a, let us derive how we can know for the numerator. That is the numerator. We can write. So we can, how we can derive the numerator? Let us see. We know the conditional probability. Let us know for the numerator first. D condition A1. Okay, that is already we know that from D condition A1. This can be written as this is the conditional probability. If you multiply, so it will be A1D equal probability D A1 multiplied by A1. This is equation 2. Okay. Now we get the numerator for equation 1. Okay, a1d we can write as a d(a1) condition multiply a1. Okay, now for the denominator probability of d, total probability, there is a law that is called the law of total probability. So any event, only this event we can write in conditional way. The event, see, event always first. For that we have two events, other event. So probability d condition a1 multiply probability a1 plus probability of d, that is for d only d condition a2 multiply a2. If there is three event, will be plus probability d condition a3 multiply probability a3. Okay, for two events we can write the total probability of this. Now putting the value of equation 2 and 3, that is for the numerator a intersection d, if you see a intersection d and probability of d for equation 3, put in the value in equation 1, we will get it. Now our question, how we can know that in common what is the probability? There is a a1, that is what is the probability of a1 condition b is d is there. How we can know? So see, if we write it, there is another condition. So we want to know probability of a1 when d is given, we can write opposite way. Okay, d a1, that a1 is multiplied there. Similarly, that upper part is again coming here. Okay, and see d, we always write the fixed, d is fixed, and we have other even a2, then multiply a2. Okay, this way we can derive the Bayes theorem. So this is the way from one condition, unknown condition, we want to know the unknown conditional probability from the known conditional probability. See, all are conditional probability here, all are conditional. We know the a1, so this will be, sorry, a1, and this will be also a1. Okay, so we can know the from the conditional from the unknown conditional probability, we can derive the unknown conditional probability. Okay, this is the Bayes theorem. And also if you want to know, and also see, this is the total probability. If we know the total probability d, then the Bayes theorem can be written as like this. Okay, can be written like this. If we know the total probability of d, that is probability a condition d, we want to know that will be d condition a1 multiply a1, and as usual the conditional law. If we know the total probability, we can also write the Bayes theorem like this. Okay, this is also, you can let us put in a box, it will be better. Let us put this in a box, also in the Bayes theorem. Okay, so you can write the Bayes theorem also like that. So a1 condition d, we can write d a1 multiply a1, again d a1 multiply a1 plus d a2. See, always don't forget the common thing always coming the first. Okay, don't be confused. This common thing, put the fixed. Okay, similarly for a2 we can write probability d, see, opposite. Similarly for a2 condition d, that is a2, even a2 in d, that is in common space, what the probability, there will be a2 even. Okay, so you can write opposite. Okay, d a2 multiply a2 plus, again that is coming d a2 multiply a2 plus d a1, the d is fixed, always the fixed item is coming first, a1 plus a1, that is we can write the denominator like this. Okay, the first one. Okay, only for the probability of conditional probability, numerator changes, denominator coming all the total probability. How many even doesn't matter. Similarly, we can write like this also. You can put in a table. Okay, so put this in a table will be better for you. Okay, so similarly for a2 in d, we can write probability d a2 multiply probability of a2 and total probability. Or if you don't know the total probability, you can put the conditional probability. Okay, this is the main of the Bayes theorem. Now if there are three events, Bayes theorem not only for the two events, you can write how many events you have, 3 4 5 6. Now if there are three events, a1 a2 a3, so probability of a1d, you can write probability d a1 multiply probability a1, that is this first one is coming here again. Okay, see, always the common thing is fixed, d a1 probability multiply a1 plus d a2 multiply probability a2 plus d a3 multiply a3. Similarly for a2, that is the which probability we want to know, that will going to the, that is opposite condition going to the numerator, d a2 multiply probability a2. Okay, that is the denominator is the total probability of d, that is can be write as a conditional probability. Okay, from the law of total probability. Similarly a3d, the numerator is going a probability opposite d condition a3 multiply a3, the denominator is always probability of d, the common item. Okay, so if you have the k events, then you can write probability like this. Okay, how many events doesn't matter. The Bayes theorem you can use. This is the main of the Bayes theorem. When just revision several times, if you have given some probability, total, this is the probability of A1, A2, and that probability, that common thing in A1 and common thing is A2, you know, you can find the opposite probability. That what the probability that even first event will be in the common, okay, opposite. Okay, we can find. So Bayes theorem very useful. Now we'll do an example. It will be more easier to us. Okay, so there is example is given. In a city, there are 60% male. So you know that probability can be expressed in percentage and 40% female. Okay. So order given. First one, this is that number one is given. So number one is given. Probability of male 60%, 0.06. When you are getting the question, first of all, write down what are the things are given. Okay. Then you can understand what to do. Conditional probability, or marginal probability, addition law, multiplication law, or conditional law, or it may be Bayes theorem. First of all, write down what's again. So probability of female, number 2 is given, probability female, 40% is 0.04, and it is known that 20% of the male and 5% of the female have diabetes. That is 20% of the male. Among the male, this meaning among the male, 20% have diabetes, and 5% male. Among the female, 5% have diabetes. So we can write this is number 3. So diabetes is common for the male and female. So we have we have find out diabetes is this common D. Okay, let us denote by D, and male is denoted by M, and female is denoted by F. Okay, so this means suppose this number 3. So number 3 is given, that is diabetes among the male. Okay, so we can write down diabetes among the male. So we can write, so diabetes among the male. So diabetes diabetes among the male. Okay, so similarly number 4, we can write diabetes among the female. So number 4 means diabetes among the female. Okay, diabetes among, like this, diabetes among the female. Okay, we can write this is as a diabetics. So you can write down diabetes among female. Okay, so 5%, that is D condition F, the D in A. Diabetes among male, D condition M, the D in M is 20%, 0.02, and diabetes among the female is 5%, 0.05. So these 4 things are given, and my condition is, my question is, what is the probability that a male will have diabetes? And number 2, what is the probability female will have diabetes? Okay, so I want to know in the diabetes there is how many, what is the probability that will be female. Among the diabetes, what is the probability the selected person will be female. So I want to know probability, that is, probability that is will be male, selected person will be male among diabetes. Okay, so for the diabetes, so among the diabetes, how many females? So how can you do it? So we know all the things, so we can write opposite. So diabetics in male, so we want to know male, how males in diabetes. Okay, in the diabetes patient, how many there will be male. Okay, so according to Bayes theorem, I can write according to Bayes theorem. So according to Bayes theorem, we can write probability of male in diabetics in opposite way. Probability is, see, always please remember what is common. Common is diabetes. So diabetes coming first. Okay, diabetes in male multiply probability of male. Okay, we don't know probability of diabetes, so we have to numerator also will be. So first one, diabetes and male is coming here, plus diabetes common thing, not male. The second, first event is male, second is female. In female, multiply female. So now putting all the value points. So male is 20%, diabetes male. So diabetes among the male, the 20% chance. So we write 0.2, 60% male. So right here, and putting here 5% diabetes among the female. We know 5%, and probability of female is 40%. If you do it, it will be 80 0.857. That is, we can write in percentage when better 85.7%. So among the diabetics, there are 85% 7 male. If you want to write, so among the diabetics, patient. For the comment is very important for statistical inference. Please don't forget to write the comment. So here comment will be among the diabetes patient. Among the diabetes patient, there are 85.7% male. So we got 20% male diabetes, but among the diabetes, there are 85.7% male. Similarly, what is the probability you select a patient, a diabetes patient? What is the probability that the diabetes patient will be female? That is probability in diabetes that the patient is a female. So similarly, by the Bayes theorem, we can write diabetes in diabetes condition female multiply female. Similarly, that the denominator will be no change. We got it 0.14. Just put the value. If we do, it is coming 0.143. That is 14. That is, you can write equal 14.3%. So can you guess the comment? First one, you wrote the among the diabetes patients, there are 85.7% male. So 20% male have the diabetes patient, but among the diabetes, the chance is also higher, 85.7%. Similarly, for the female, you can write among the diabetes patient. So among the diabetes, there are 14.3. As the only 5% females have diabetics, so also among diabetes patients, there are 14.3% females. So this is the comment for the diabetes. Number 3, what is the total probability of diabetes? You don't know probability of diabetes. We select a patient, so only diabetes. My question, what is the probability that patient will be diabetes? Not male, female, maybe male or female. I want to find the common thing. See here, what is the probability of this D? Common, okay? Not A, not A, B, all A and B also will be there, maybe male or female. So how can you do? As I told before, the denominator is the total probability from the law of total probability. How can you do it? See. So from the law of total probability, so number 3, let me solve. What is the probability of diabetes? So according to law of total probability, so diabetes patient will be, we can write like this. Let us see, how can we write number 3? So let us solve number 3. 1, 2, 3. Let us solve number 3. So probability of diabetes, because any, so according to total probability, diabetes will be this, okay? Probability, so we have probability of diabetics. We can write probability of diabetes is there nothing but the denominator, okay? And what is the value of denominator we got? We got it 0. As I think it will be 0.14, okay? 0.14. So in percentage, it will be 0.1%. 14% chance. So what is the comment? The overall rate of diabetes patient is, you can write the overall rate of diabetes patients. Here male, female doesn't all included in the common space. The diabetes patient may be male or maybe female. So chance of diabetics, the overall rate of diabetes patient, diabetics among male and female. You can write among male and female. Among diabetes, you can write in the bracket among male and female is 14%. So we got for the male, there is 20% chance diabetes, and for the female 5% chance. But if you consider not male, female, there is 40% chance the patient will be diabetes, whether male or female. So this is the comment. So in this way you can write, but please, when you are getting the question, first of all, write down what are the conditions are given. Okay, what are the conditions given? Please write down. Please write down what are the conditions are given. It will be better for you. Then you can summarize. You can do addition law, condition law, multiplication law, or by the Bayes theorem. Okay. So I think there is another method. So please, I give some hints for you. So suppose there is a new screening test proposed for the detection of fracture. You know the fracture. The prevalence is the number of patients in general population is known to be 10%. That's 10% people are suffering from this the fracture. The test, has been investigated fracture subject and found to give positive result in 70% of such cases. That is, somebody have the, the sense we will learn later on. Somebody have the fracture. Also, it is tested positive. That is called sensitivity. It is 75%, and the test and also positive result for 20% who do not have the fracture. This is a wrong result he that, and 20%. So 70% the correct result for the fracture, who have the fracture, and 20% is no fracture. So let us see what is given. So let us see if even if is a fracture, and the probability of fracture is given 10% all over the world. This is a common probability. I think all over the patient is 10%. And positive result plus B is the positive test result, and it is given the positive result among the fracture is 70%. This is given. So it will give the positive result for the who have truly fractured, it is 75%. Okay. And not fracture, that is somebody have do not fracture but giving the positive result, that is plus B on not fracture. Okay. So what is given? First, probability of fracture is got, and probability of positive result for the fracture is 70.07, and probability of positive result if we do not have the fracture is 70%. Sorry, it will be 20%. Please make it correction. It will be, as I think it is 20%. Yes, 20%. And so 20% is 0.02. So what is common? If you see, we have the probability fracture is 10%. What is common? The positive test result. We are getting positive test result for the people who have the truly have the fracture. Also, we are getting the positive test result who also have the fracture. Now, my question is, we want to know the probability proportion will actually be found to have fracture with positive test result. So, somebody have the positive test result. We want to find what is the probability that the person have the fracture. We want to find the probability of fracture, positive test result. So, according to Bayes theorem, we can write what? Opposite. Okay, probability positive test result given fracture plus probability positive test result, probability of fracture, same thing will come, plus probability positive test result not fracture, that is somebody that is the with second opposite, and probability of fracture. Okay, not fracture. Okay, so if you put all the value, and remember that probability of not fracture can be found from this complementary law. Fracture probability 0.1 and probability not fracture will be 1 minus 0.19% from the complementary law. Okay, this is from a complementary law. Complementary law. If something probability not A, probability 1 minus A. So not fracture, 1 minus fracture. Okay. So in this way you can solve it. Okay. Please try. I already give everything. Please try it yourself. That's all. Please more practice. I'll give you the practice sheet as the assignment. It will be better for you. But for Bayes theorem, as you do more practice, it will be more easier. But after getting the question, summarize all what are the things are given. Okay. So if you have given two conditional probability, you want to know the other conditional probability, you can do it. If you have the total probability, also you can do the Bayes theorem. Okay. Good luck. Just make more practice. It will be better for you.